Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you see the links for the O-level and the A-level group. Welcome back, friends. This is Dr. Mlelwa Lecturers, the facilitator in this session. I am Dr. Mlelwa, and in this session we are going to continue about the different ways to represent the amount of a substance. As we discussed in the previous session, that we have mass concentration and then we have molar concentration, which we call it as a molarity. So in this session we will go to look about another way of representing the concentration of substance, which is a molality, with L here abbreviated as small m. Now, molality is the number of moles of solid dissolved in 1 kilogram of solvent. Number of moles of solute dissolved in 1 kilogram of solvent. So simply m unit yake itakuwa ni mole per kilogram. Itakuwa ni mole per kilogram. So it's different from molarity ambayo tunaifahamu, ambayo ni sana ni unit yake ni mole per dm cube. So it is quite different. Hii ni number of moles of substance dissolved in 1 liter of solution. Ukiambiwa kudefine hizi, be very careful. This is 1 liter of solution. This is 1 kilogram of solvent. Now, molar solution, molar, not with R here, it is with L. Molar solution, the solution that contain 1 mole of solid dissolved in 1 kilogram of solvent. Now, here we have the difference. And we have the question, for example, distinguish between molarity, and molality. Distinguish. And for this question, for the case of this question, we are just answering it by basing on the definitions, their definitions. But here, let's discuss a little about their difference. Now, molarity measures the concentration of solidity in a solution as a relative amount of solidity to the mass of solvent. You see? This molarity measures the concentration of solidity in solution as the relative amount of solidity to the mass of solvent in a kilogram. But molarity is the measure of concentration of solidity in a solution as the relative amount of solid to the volume of solution in liters. So one quantity relates to the mass, another quantity related to the volume. Now let's see the effect of temperature on molality and molality. That which one is affected by temperature? The molarity with L and the molarity with R. Molarity. Which one is affected by temperature? As we said that all of them, they have the numerator, which is the number of moles. The difference now is on the denominator. Denominator of molarity is volume of solution, while denominator of molality is mass of solvent. Now, if we increase maybe temperature, we know we studied in Form 3 physics about the expansion, and we discussed about the thermal expansion in liquids. That if we increase temperature, the volume of liquid can increase. Also, however, we have the abnormal expansion, for example, in water, which by increasing temperature, by decreasing temperature, also the volume increase, as how you could increase the temperature. But I don't want to discuss about the matters of abnormal expansion of water here. Now, we are talking one thing, that because volume of a solution is affected by temperature, and mass of a solution is not affected by temperature. Now, the quantity which depends on volume is the one which will be affected by temperature. Kwa hiyo kwa sababu molarity inakuwa affected na temperature, basi yenyewe tukibadilisha temperature pia yenyewe itakuwa affected. So volume of tunasema kwamba molarity is the temperature dependent while molality is not. Volume of a given mass of solution increases with an increase in temperature. This means that the molarity also will decrease as the temperature increases. Why? Because as we said that molarity is equal to number of moles divided by volume. Now molarity M is in inverse proportion to volume. Expansion due to increase in temperature will increase volume. Thus, this will lead to a decrease in molarity. You see, increase in temperature will decrease molarity, and a decrease in temperature will increase molarity. However, as I told you that you have the abnormal expansion of liquids like water, and most of the solutions they are made up of water. So, in contrast to volume, mass of solvent does not vary with the temperature. This means that molarity of a solution, molarity of a solid in a solution remains constant on temperature change. Now, molarity being a temperature independent is the main reason of preferring it to molarity in application. So, molarity tunaiprefer zaidi, hii ya kutumia elo tunaiprefer zaidi kuliko nani? Kuliko molarity. So we prefer molarity ambayo haichange na temperature kuliko ile ambayo ina change na nani? Na temperature, because in some of the experiment the temperature changes. Kwa tukitumia ile ambayo ina change tutapata shida kwenye interpret the results. So you have the question, for example, question: molarity is more preferred as measure of concentration of solid compared to molarity. Kwa nini? Utoe reason. So the reason is very easy. Tumeshaelezea kwa sababu moja is affected by temperature, another is not affected by temperature. Molarity is preferred more. No, this is L. So molarity is preferred more as a measure of concentration of salt because it does not vary with the temperature. That is, it is temperature independent since the mass of solvent is constant, as compared to the molarity where the volume of solution varies with the temperature change. But the advantage of molarity now, molarity is an advantage kuliko nani? Kwa nini? Kwa sababu it is easier to measure the volume of a liquid rather than to measure a mass. Yani kwenye molarity tunatumia volume of solution. It is easier to measure the volume of liquid rather than mass. So, but the advantage of molarity is that it is easier to measure volume of solution using precisely calibrated volumetric flask than weight of solvent. So to weight a solvent is very difficult because different flasks, they can have different masses. So you may approximate the mass of flask, but most often you may see that the calculated mass which you take it is incorrect. Now let's move to the another quantity which is called the normality. Normality is the number of equivalent of solid dissolved in 1 liter of solution. Number of equivalent of solid dissolved in 1 liter of solution. Now, this quantity is not normally used, and even the molarity with L, I know it's the new quantity to most of you students, and even in O-level, for those who studied the previous years, walikuwa naitumia normality kwenye miaka 90 walikuwa naitumia kwenye O-level calculator, lakini in nowadays O-level it is out of syllabus, so it is studied in advance. So normality is equal to number of equivalent divided by volume. Now we want to see the relationship between the molarity and the normality. Number of equivalent when you are saying about number of equivalent, is equal to mass of solid divided by equivalent weight of solid. Mass of solid divided by equivalent weight of solid. Now, if you substitute this formula into this one, which is the first one, you get normality is equal to mass of solid divided by equivalent weight of solid times volume of solution. Equivalent weight of solid times volume of solution. Now we know mass of solid divided by volume of solution in liters, it is mass concentration. So mass of solid divided by volume of solution in liters, it is mass concentration. So now normality up to here will be equal to mass concentration divided by equivalent weight of solid. So normality is equal to mass concentration in gram per dm cube divided by equivalent weight of solid. So equivalent weight is equal to molar mass divided by valence. Equivalent weight is equal to molar mass divided by valence. So it depends. In acid-base titration, we are taking the acidity and basicity. So, for example, in acid-base titration, basicity is the number of hydrogen ions given in solution when acid dissociates. For example, tukiwa na sulfuric acid ikidissociate inatengeneza 2 hydrogen ions. So this is the basicity of hydrochloric acid. I mean sulfuric. Lakini tukiwa na hydrochloric, for example, tukiwa na HCl ikidissociate inaenda kutengeneza nini? 1 hydrogen plus chlorine. So the basicity is 1. Kwa hiyo inategemea na type ya base yako. While acidity is the number of hydroxide ion given in solution when the strong base dissociate. So basicity, for example, for sodium hydroxide, ikidissociate in the solution napata ni sodium plus hydroxide ion. So because you got only single hydroxide ion, basicity yake ni ngapi? Ni 1. Now normality katika acid base titration, normality in acid base titration, we are taking it as molarity, molarity times basicity or acidity. That is the calculation of molarity in acid base titration. Also in redox reactions, we study later in electrochemistry. In redox reaction, normality is equal to molarity times number of electrons transferred. Hicho kitu kimetoka wapi? Kama tulivyosema kule mwanzoni, kwamba normality is equal to mass concentration divided by number of equivalent of solid. Number of equivalent. Now we said the number of equivalent is equal to molar mass divided by valence. Now taking this into that formula, we get normality. Normality is equal to mass concentration ile ilikuwa ni mass divided by volume, and number of equivalents is equal to molar mass divided by valence. So hii valence maana yake hapa itapanda juu. This is mass concentration. So normality will be equal to mass concentration divided by molar mass is equal to molarity. And then valence itapanda juu itakuwa nini? Times valence. So in acid base titration, valence inakaa basicity au acidity inakaa badala ya valence. Na kwenye redox titration hapa inakaa nani? Number of moles transferred, number of electrons transferred, sio moles, number of electrons transferred. Kivipi? Kwa mfano, a redox reaction involving the manganese, tutakuwa na manganese hapo O4 ile pale ameenda kutengeneza nini? manganese pale 2 positive plus 4 H2O. How many electrons they've been transferred? Hapo inabidi balance a chemical reaction. Tutaenda kusoma vizuri kwenye electrochemistry, lakini unatakiwa balance chemical reaction. Kwa kwenye kubalance hapo kwanza una add hydrogen kwenye hii side ambako kuna, kwa hiyo una add hydrogen zibalance na za huku. So tutakuwa na manganese O4 negative plus, hapa hydrogen ni ngapi? Ni 8 hydrogen ions. Tunaenda kupata nini? Manganese 2 positive plus 4 H2O. Then tuna balance charge. Kwa kwanza tumesha balance hydrogen, tukisha balance hydrogen tunaenda ku balance charge. Charge hapa ni ngapi? This is positive 1, negative 1, positive 1, positive 80. Positive 80 na negative 1 nabakia ngapi? Positive 7. This is positive 2. Kwa tunahitaji ngapi? 5. So it will be manganese O4 negative plus 8 H positive. Tunahitaji ngapi? Negative 5 iweze ku decrease. So plus 5 electrons yule pale tunaenda kupata nini? Manganese 2 positive plus manganese 2 positive plus 4 H2O. So hizi ndo nini number for electrons transferred kutoka kwenye hiyo equation yetu. So normality kama kwenye titration kama hiyo, kwenye hiyo redox titration kama hiyo, tungechukua molality times C, the number for electrons transferred ambazo ni 5. So the number of electrons transferred kwenye hiyo kesi yetu ni basicity and acidity. They are used the number of moles transferred, basicity of an acid or acidity of a base are collectively called the equivalent factors. Kwa jina moja zinaitwa equivalent factor. So actually we can summarize as a normality is equal to molality times equivalent factor. Molality times equivalent factor. So let us end up here. In the next session we'll be discussing about the concept of mass, percentage and mole fractions and etc calculation. Kwa hapa tuna calculate kama basics, to basics na formula, tuna calculate to basics, lakini tutaenda kuona kwenye calculation zinatumikaje. Thank you everybody, don't forget to subscribe the channel and to share the link for this video to your fellow students. Thank you. Let I wish you nice studies.